All right, I had to make sure that we were on that. We were on the same page.
So try to behave tomorrow. So this chapter is all about conic sections, and there are 4 different conic sections that we're going to look at. Okay? These are called conic sections because they're formed when we take 2 cones that are right on top of each other and put a plane through them at different angles. Okay? So the 4 conic sections that we're going to look at are a circle. Okay? If I take my cones that are right on top of each other and I put a plane completely perpendicular to the base of one of the cones, right? I guess perpendicular to the axis, parallel to one of the bases, I'll get a circle. If I tilt that plane a little bit, I'll get an oval, or we call it an ellipse. If I tilt it even more so that it's only going through one side of the cone, we get a parabola. And then if I tilt it even more so that it goes through both cones, we get a hyperbola. Right? Hyperbola. So, this first section is just a basic overview with a little bit of vocab. So, the point that's in the middle of a circle, an ellipse, and a hyperbola is just called the center. So, I guess, you can see what those figures look like in that 3D model up there, but I guess maybe we should talk about what they look like on a 2D model. That's what we're going to be working with here, is graphs of these figures. So, we know what a circle looks like. The circle looks like this. An ellipse is just an elongated circle, or an oval. And we know what parabolas look like, but we're going to look at parabolas that open up or down, and also left or right in this section. Okay, so parabola, and then a hyperbola. Okay, it's just kind of, it could open left and right or up and down. Okay, but a hyperbola is just kind of a double parabola. Okay, those are what the 2D versions of these shapes look like. So, for our first vocab word, okay, the point that's in the middle of a circle, an ellipse, or a hyperbola is called the center. In the case of a parabola, okay, the point that's at the end. In the case of an ellipse, okay, an end of, and we'll talk about what a major axis is here, okay, but end of the major axis, and then in the case of the hyperbola, these points here, the turning points, all of those points have one name. They're all called the vertex. The next one, okay, a point from which distances are measured in forming a conic, and we'll talk about each of these as we go through each one individually, but we call this the focus. Okay. The plural form is foci. A line from which distances are measured in forming a conic. We call this the directrix. And again, we'll talk about each of these when we go through each of these conics individually. The next one, a line perpendicular to the directrix, passing through the vertex of a parabola. This is one that we have talked about before. Right? So if you've got a parabola line going right down the middle, like that, is called the axis of symmetry. And then, if we're talking about an ellipse, we have 2 more. The first one, a line segment perpendicular to the directrix, passing through the foci. That's going to end up being a line right through the middle of an ellipse like this. That's called the major axis. And then the last one, a line segment perpendicular to and bisecting the major axis. So that's going to be a line going through the middle in the opposite direction. This is called the minor axis. Okay, so again, we'll talk about each of these things individually when we go through each type of conic section, but just so we have a list of vocab terms here at the beginning. So, equations of each of these four different types of conics in the general form could look like this. Okay, so there's a couple of key things for each one of these. In a parabola, okay, we notice only one variable is being squared. Okay, it could be x squared or y squared, but in a parabola, only one variable is squared. Okay, that's how we tell if we have a parabola. In the other three, we'll have two different variables that have squared terms. For a circle, okay, we have an x squared and a y squared. What differentiates a circle from the other types of conics when we're looking at the equation is the coefficients on the two squared terms are equal. Okay? Coefficients on the two squared terms are equal. Now, the difference between a circle and an ellipse is that the coefficients on the two squared terms are not equal. Okay? Coefficients on my two squared terms are not equal. So for all of these, we could have lots of different things added on, and we could have x's and y's and constants. Okay, but the key thing that we're looking for to determine whether or what type of equation we have are these. Square terms are different. And then finally, for a hyperbola, okay, we still have two squared terms, but one of them will be negative. Okay, for both the circle and the ellipse, both of our squared terms were positive. On a hyperbola, one of the squared terms will be negative. Okay, and as we go through these sections to look at each of these types of conics in detail, we'll talk about a standard form that we're going to use that will make these much more obvious that we're dealing with a different type of conic. But if we're given the equation in general form, this is what we're looking for. In a parabola, we have one squared variable. For a circle, both x and y are squared, and the coefficients are equal. For an ellipse, the coefficients on the x squared and y squared terms are different. And for the hyperbola, one of the squared terms is negative. So, let's look down at these four examples, try to figure out which conic is represented here. So in A, if I look at my two squared terms, coefficients are equal, both positive. So that means this is going to be a circle. In B, there's there's only one squared term. Parabola. C, we have two squared terms. Coefficients are different, but they're both positive. So this would be ellipse. And finally, one of my squared terms is negative, so hyperbola. Okay? Feel okay with that idea? Okay, so that's actually all that is in this section is just a super basic overview of the four types of conics. But if you remember all the way back in chapter 2, we were supposed to talk about circles. And I said we'd save that for the conics section, or the conics chapter. So it's that time now to talk about circles.
But Mr. Fetch, I don't want to talk about circles.
I don't care. We're going to do it anyway.
I'm going to cry.
Okay. So, a circle, the basic definition of a circle, is just the set of all points that are equidistant from a given point. Okay? That given point would be the center of the circle. Right? So we're taking every single point that is the same distance from the center of the circle. That distance would be the radius. Right? So we're essentially saying, here's my center, I'm going to take the radius and take every single point that's that distance from the center. That's our definition of a circle. So we just looked at the general form for a circle. The standard form is like this. Okay, x minus h squared plus y minus k squared equals r squared. So from this, okay, if we have our circle in this form, I can get a couple of pretty important pieces of information. The point HK would be the center of the circle, and R will be the radius. So if we look at this first example here, x plus 1 squared plus y minus 3 squared equals 16. From that, I want to get the center and the radius of this circle. So if we notice in our standard form, I'm subtracting both h and k. So essentially what that means, if I'm looking at my equation, I'm just going to take the opposite of both of these values to get my center. So the center of this circle is going to be -1, +3. And then the radius is going to be the square root of this number. Because if we look at our standard form, this is equal to r squared. So to get the actual radius, we need to take the square root of this number, which would be 4. And I guess write it as the square root of 16, which equals 4. Remember that we're taking the square root of whatever this value is. So try the second one. Tell me the center and the radius for B here.
Do you have tissues in one? I
I
did.
think I'm out.
Bruh, I'm gonna go freaking tissue my nose.
Tissue nose.
I will literally just plaster tissues onto my face so I don't have to go get them.
That makes sense.
And then I'm like, oh, maybe I have more nose.
Did we get 1/2, 0, and then the radius is 2/5? Okay. So we know to take the square root of a fraction, we're just taking the square root of the numerator and separately the square root of the denominator. So the square root of 4 over the square root of 25 would just be 2 over 5. So let's take a look at graphing. If we have this equation, how would I graph this? What pieces of information would I need to graph this circle? Center is at 4, 5. Right? Radius is 3. So that's all the information I need to graph the circle. There. We go to the point 4, 5. And then I go 3 away from that. Right, left, up, and down. And then I sketch my circle. Okay, it's not going to be exact, but okay, that's the idea. Right? Getting the center and the radius, and then we can sketch a pretty good picture of what this graph is going to look like. All right, how about this one? X squared plus y minus 5 squared equals 18. What's the center and the radius for this? Center would be at 0, 5. And what's the radius? The square root of 18, right? Which, if we wanted to simplify that, we could break that into the square root of 9 times the square root of 2, which would be 3 radical 2. Which,
Don't start.
as a decimal, would be like 4.2. Probably, yeah. I want it like that.
What was the center of the last one? Or not that one, but the one before it. Was it just
1/2, 0.
Okay. I wanted to make sure I wasn't being stupid. Hey, you did that.
Right. Now, what about a number 3 here? If we're given a graph, how could I write the equation? The center is at -4, 3. What's the radius? Radius looks like it's 5. Alright, so what would my equation look like then? X plus 4, because remember we're taking the opposite sign. So x plus 4 squared plus y minus 3 squared equals 5 squared, which would be 25.
So I heard a lot of yeses.
Yeah. So most of that's pretty straightforward, right? Now what if we're given the equation of a circle in general form, and we want to put it into standard form? Okay. To do this, we're going to have to complete the square twice.
I did hear a lot of those. Do you have 30 seconds? I can do it. Oh, crap. Alan. You know what's funny when you're going to sorry about that. Anymore. Yeah, but did you see where it was specifically?
So, to set this up. To set this up to complete the square twice, we want to put our x variables together and our y variables together. So the way that we're going to organize this, okay, I'm going to set this up as x squared minus 4x plus blank. Then plus, and I'm going to collect my y terms, so plus y squared plus 8y plus blank. And then whatever my constant term is, I'm going to go ahead and move that to the other side. Okay, so I'm going to add 5 over to the right side. So I'm going to write that as equals 5 plus, then I need to account for these two blanks. So plus blank plus blank. Okay, so we're just collecting our x's, collecting our y's, and then to complete the square, we're going to set it up as adding a blank to both of those. To complete the square, we're going to take half of our b value and square it. Okay? So in this case, half of negative 4 is negative 2. Negative 2 squared is 4. Okay? And if you want to make a note that this value here is b over 2 squared, okay, it might be a good idea to make a note of that. So if I do this, well, so if I'm adding 4 here, I'm adding 4 over here. And whatever we do to one side of the equation, we have to do to the other side. So I'm going to do the same thing here for the y's. Take half of b and square it. So that would be 4. 4 squared is 16. So then I'm going to add 16 to this side as well. So the reason that we do this, we've now created perfect square trinomials. So this will factor now into something squared. Do you remember how this factors?
Negative 2 and negative 2.
Negative 2 and negative 2. So, I mean, you can always x factor, but the shortcut, right? This value right here is always just going to be b over 2. Okay? So to get this value, we take b over 2 squared. This value right here is always just b over 2 less. Okay, so when we took b over 2, we got negative 2. That tells me this is going to factor into x minus 2 to the second power. Do the same thing for the y's. So this is going to factor into something squared. So what is this one going to be? Y plus 4. And then equals 5 plus 4 plus 16 is 25.
Yes.
So now, by completing the square twice, we now have this equation in standard form. We can just look at the equation and see the center and the radius. So what's my center? 2, negative 4.
Like so.
And the radius?
5.
5. Okay. Questions? I want to do one more example that's not on here. I'm going to make up a problem here.
Imagine if you had to make these books and your job every day, all day, was making math problems.
That'd be kind of cool.
I don't think that'd be very cool.
I mean, now I understand how many watermelons has.
You got to write so many of these problems.
Yeah.
All right, so let's say
How many digits? What's a real life application for matrices?
Solving three system equations.
What's a what do you use systems of equations for?
Solving systems.
No, I mean like systems of equations themselves. What do you use those for?
Finding variables.
I mean, we went through like some simple story problems, but
Oh, like with the sheaves?
like the sheaves.
I remember. I could never forget the sheaves.
All right. How about something like this? Write the equation of a circle centered at 1, 2. It goes through the points 5, 6.
Okay, bro.
How would we do something like this? Any
And
ideas?
is the 0.56?
Wait, say that again.
Is it end of the 0.56?
Circle.
Like, is that like where, like... Oh, so yeah, that's where it would intersect.
Yeah. So, I mean, if we think about graphing this, right, we're at 1, 2. So here's the center of the circle, and then 5, 6, and then it goes through this point.
Do you need to do the
You
distance
have to
formula?
do distance formula, and I don't feel like...
No! I don't want to do the distance formula, Mr.
I don't even
Fag.
remember what the distance formula is.
Distance between these 2 points is going to be the radius of the circle, right? So if this is my center, and the circle goes through this point.
Sir, what do you do distance on your calculator?
No, not really.
But you
But-
solve matrices?
But so we don't need to have the distance formula memorized, right? The distance formula is just the Pythagorean theorem. Right? The distance formula is just the Pythagorean theorem. So if we have something like this, all we're doing is finding the hypotenuse of a right triangle with this leg is 4, right? And then this leg is also 4 in this case, because we're going from 1 to 5, and then we're going from 2 to 6. So all the distance formula is a simplified version of the Pythagorean theorem. Okay, so you don't have to have the distance formula memorized. All you're doing is the Pythagorean theorem. So to find this length, we're doing 4 squared plus 4 squared equals, this is the radius in this case, so I'll call it r squared.
So if the distance from points from x to y are the same, then the distance is that number. Like the distance from 1 to 5 is 4, 2 to 6 is 4. So, you know what I'm saying?
Yeah, all we're doing is looking at the distance from the x's, the distance.
And if they're the same, then you know the distance. So I mean, you can just check that.
Wait, what do you mean?
Like if the distance from 1 to 5 is 4, the distance from 2 to 6 is 4, then the distance is 4.
This distance is not 4.
Oh yeah.
Because we're going to have to add these together. Right? So 16 and 16 is 32. So we get that r squared is 32, or the square root of 32 then for the radius. Okay, so if we wanted to simplify this, we can make this 16 times 2, which would just be 4 radical 2.
Hey, it's almost 4.
So if I wanted to write the equation of this circle, and if we're thinking about x minus h squared plus y minus k squared equals r squared, well, my h and my k are my center, so 1 and 2. Right? So this will be x minus 1 squared plus y minus 2 squared equals square root of 32 squared, which is just 32. Right? We have our r squared all the way up here, which would just be 32. If you're asking for the equation, no. If it asks you for the radius, then yes. But if it just wants the equation, all you need is r squared. Okay. questions?